Okay, so on this one, find the area of R. What's the first thing you need to do?
Find the point.
And you must use your what?
Calculator.
Calculator. And here's the thing. Who found that intersection point right there? When you get it, write it down if you want to, but also store it. Also store it as like a number, a letter on your calculator. So you don't have to keep on typing it over and over and over again. So let's do this one out on our calculator. What should you do? Intersect, right? So second calc, intersect. Was it first curve, second curve, and then it asks you for the guess. So let's guess right over here. And there it is. X is equal to 0.17. What you should do at this point, if you go back to the main screen and hit X, it's stored already as X. But why is it dangerous to keep things stored as X?
Because that changes.
It changes all the time. Every time you run something like this. So what you can do is you literally can do X, store it as, let's say A. So now every time I do A, what is it? That's what it is. So on your test paper, you could write A equals this. And then do you ever have to write that decimal again?
No.
No. Okay, so we go back to our graph right here. We want the area of region. What do we want the area? We want the area of region. It's a little bit different, but not so much. I'm going to go to math, and then what? Function int, right? Correct? And I'm going to go from 0 to what? You can literally put A right there. And for our function, what am I going to do? It's going to be vars. It's going to be, no, y2 minus y1. And this is just the math type. It's slightly different, but you can write the exact same thing. You go enter, and then you get this. Does that match what you got?
Yeah.
Okay. The true, I think it's called not. Okay, so we did the second intersection is 1. So then the second one is just going to be the integral from a to 1 of what? F of x minus g of x dx. And what can we do here? We can do second entry, right? And what's it going to be? Alpha a all the way to what? 1. Oh, sorry, my fault. A to 1 of y1 minus what? y2, and it's dx still. We hit enter. We end up with 0.4. Should it be larger? It should. Logically, does it look like a larger area?
Yeah.
Yep. So let's just take, oh, that's really tiny. It does that sometimes when I click inside a layer. If you're going to look at this question, it might be good to look at what is true. Where it's, where it equals 0. Where it equals 0. So we want to know when ln of x minus 2 is equal to 0. Well, that's when e to the 0 is equal to x minus 2, right? So that's when 1 is equal to x minus 2. So that's when x is equal to 3, right? So you have x is equal to 3. You know that this function ln of x minus 2 is equal to 0. If it's greater than 3, what happens? It's positive, right? Do you agree with that? And if it's less than 3, it's negative. But what's the domain of ln x minus 2? X has to be greater than or greater than what? It has to be greater than 2. Because if it's equal to 2, you have the ln of 0. Can you take the natural log of 0? No. So this is canceled because it's not in the domain, right? So what are you looking at? You're just looking at from 2 and 3. Now, is this the type of question that's going to appear in the AP test? Not really, because this is strictly a pre-calculus question. There's no real calculus involved here. That being said, could it be crucial to your finishing a calculus question to know what the domain of a natural log is? Absolutely. Deep thoughts by my calculus classes. We know how to do it, but we just don't know how to do it. Pause. Carefully do this out. You end up with 2x plus 5, right? And then you end up with plus and minus the same thing in the middle. And then end with minus x plus 7. The radicals are gone in that. And what are you left with on the bottom? X minus 2 times root of 2x plus 5 plus root x plus 7. What does, and this is the limit as x goes to 2, right? What does the top turn into? 2 over x minus 2 times this thing, right? What cancels? So you're left with the limit as x goes to 2 of 1 over root 2x plus 5 plus root x plus 7. Now, can you actually plug in 2? Yeah, that's equal to 1 over the square root of 9 plus the square root of, which is equal to 1, 6. Is that one of the answers? Yes, it is. You would have seen this much more easily if the bottom had radicals in it because you've been trained to rationalize denominators. You have very few things to do when you're attacking limits. First thing is, can you simplify? Can you factor, right? No. So you're really the only thing you're allowed to do. Tony, what did you say it was? multiply by a form of 1.
In general,
And yes, sometimes it's harder to see, but in this case, look, it's you can think of it as like a conjugate. Things to remember on this one, the key things to remember are product rule, and the derivative of a constant is 0. Isolate y prime, plug in the x value. You need a y value, so you find it. Absolutely find it. That's it. Totally it.
Okay.
G double
I
prime?
didn't know if you had to like.
No.
A or anything.
What's G double prime going to be of x?
A squared.
A squared e to the plus what? Yeah, that's it. So G double prime of 0 is going to be what? A squared plus f double prime of 0. So that's going to be G. I'm just doing it out just so we have all the steps. A what? Does it tell us that value?
Yeah.
Oh, it does. Plus what? And you're done. That's it. That's it. Done. The function h is given by h of x is equal to that thing for all real numbers, where k is a constant. Find h prime and write an equation for the line tangent to the graph of h at x equals 0. To write the equation for a line, you need what and what? That's it. Point and a slope, and then you're done. Point and a slope. They're giving you the x value, so they need to find h prime. They're telling you to find h prime, and they're telling you that what h is what? H of x is,
Cosine kx.
thank you, times what? Times f of x, right? Yeah. Like that? Okay, so to find the derivative of this, what do you need to use? Product rule. H prime of x is going to be the derivative of the first, which is negative sine. Yeah, I'm going to do this out. Negative sine kx times k times f of x plus the first times what? F prime of x, right? So that's our derivative function. We need the slope at 0. So h prime of, what do we need? 0 is going to be negative sine of 0 times k times what? F of 0 plus cosine of 0 times f prime of 0. Do we have all these values? We do. What sine is 0? 0. So this thing turns into, this is 0. Cosine of 0 is?
1.
And what's f prime of 0? So h prime of 0 is? Negative 4. So do we have our slope, right? And we know that x is equal to 0, so we need to find what?
Y value.
The y value. What's our original function? H is? Oh, we have it written right there. So we need h of? So it's going to be cosine of 0 times? What's cosine of 0? What's f of 0? Does it tell us it's 2? So it's 2. So our point is 0, 2. So what do you write for the equation? Y what? Is equal to? Negative 4 times? Guys, you can leave it just like that. Can you clean it up in 2 seconds? Sure, but can you leave it like that?
Yep.
Yes, you never, as far as I know, unless specifically told, and I've never seen specifically told, you can leave it at point slope. Totally fine. Totally fine. And is there anything else on this question?
No, that was it.
That's it. Do you want to see what the answer is?
Yeah, that would be.
Yep. So g of 1, right here, is the area from, so g of negative 1 is going to be the integral from 0 to of f of t dt. So that's going from 0 to, it's going to the left, right? So it's the area of this triangle, but it's going backwards, so it's going to be equal to the integral from negative 1 to 0 of f of t dt, the opposite of it, which equals negative what?
It's actually. It should be.
Okay, the area is above, but we're going backwards, so the area is the answer is going to be negative. Look what I just wrote up there, everybody. The integral from 0 to negative 1 is the same as the opposite of, no, negative 3 over 2. Correct, Corey. What is the area of that triangle? 3 over 2.
Wait, does that mean if we go below the axis, it would be positive?
If we're going backwards, yes. The area for the answer for the integral, if you're going backwards and it was below the x-axis, would be positive. Yes. Okay. So then it says,
No, like.
this is the Matthew show right there. That's it. So for this one, let's just take a look. You can actually, if you want to see my guess, and this is really annoying when that happens. G of x is increasing when what is true? When what is true? A function is increasing when what is true? This is not a trick question.
When the
G
when the
prime of
derivative
x,
is above the x-axis.
0.
Yeah.
A function is increasing when the derivative is greater than 0. Well, we know that g of x is equal to that thing. So what? Oh, we already found out that g prime of x is equal to what? F of x. So g of x is increasing when what? When f of x is... No. When f of x is greater than 0. G of x is increasing when the derivative of g is greater than 0. G prime of x is f of x. So therefore, g of x is increasing when
X is greater.
f of x is greater than 0. Where is f of x greater than 0?
From -1 to 1.
From -1 to 1. And it's really important that you do soft brackets there, because if you do hard brackets, is it correct?
No.
No, it's not correct. B also says, oh yeah, that's it. Explain your reasoning. Well, there's our reasoning right there. That is totally fine right there. Totally fine. Let's click. We know it's concave down from 0 to 2. So how do we make it increasing but concave down? Yeah. It's going to look like what?
Yeah.
Like this, right? And what do you think the other side is going to look like? The exact same thing, but... yeah, so what's it going to look like?
It's an odd.
It's an odd function like that. Now, what point could we test? There's another point we could do here to help us out here. We could plug in which x values do you think? How about, let's just do 2. What's it at 2? What's it at 2, everybody? What's the area under the curve from 0 to 2? This is it's 0. What's the area under the curve? Oh, it's 0 again, right? So it's going to look like. There it is. Nice. So there it is. There's G. There it is.